So regional but global challenges, local solutions, just the thought on it. So Kim put forth the idea, hey, let's talk about challenges and solutions. So let's just dive right in. One of the biggest challenges we've got in our neck of the woods, which I'm sure many of you have, is that we got a housing problem. We got a major housing problem. So here's my project right in the lower middle. But you'll notice a lot of disparate areas, a lot of elbow room around these buildings. That's because a lot of our cities, especially in the West, were plotted out for the single family house with the two cars in the driveway. And that's we live in a very different world than the existing house that was there, the existing neighborhood. So you see in the over on the right side, there's the train, there's a new rail station. That's actually a state highway. And the fact that a block away, we've got single family housing, it's just not what we need moving forward. So with that, just some statistics, because we all love statistics in this crowd. In the next 20 years, the Seattle metropolitan area needs a 30% increase in its homes. 30% more homes in the next 20 years. And we all want them to be passive. We know there's so much opportunity. We want them to be denser. We want to be a part of the solution. And then when we look at Washington State, we need over 1 million new homes. This is not that big. It's not New York State. It's not Connecticut. This is actually we're one of the center tier states. We need over 1 million new homes. So again, 30% new homes for our population in the next 20 years. And let's just make sure that's all passive. So how are we going to do that? But as we think about those new homes, we also want to think about who's going to be living in them. And so of those new homes, quite a few of them are going to be built to serve a population that doesn't have the income that a lot of other folks do. So when we look at what AMI, the average median income of the occupants of these residents, about quite a few of them are going to be in this lower tier. And that's where our public funding comes from. That's what the work that Bev's been doing, that a lot of you have been doing, where we're sourcing public funding to build housing for people who don't have the income that lower levels of income. So that's what our public funding is going to do. And it's great. It's fantastic. And we want to encourage that as much as possible. Well, then there's the high end stuff, the high market value. Well, that's the market rate builders. They're out there. And so, well, what's going to happen with the missing middle? So that's where so sort of the working class, like, how do we meet the housing needs of that 80% to 50% AMI? And so that's what the strategy with this project I'm going to talk about now is endeavoring to do. So that's the goal of this organization, Red Door Sustainable Housing. There's 3 of us who are part of it. 2 of us are builders. One of us is Ginger Siegel, is a affordable housing project manager and has been in the affordable housing community for a couple decades, has been in the shelter housing prior to that. So a tremendous amount of experience in leveraging public dollars. And she and I have had this conversation for 2 decades. How can we take that knowledge of meeting the needs of for people who need housing, yet leverage the private market? And so with that, we're leveraging 3 components within this project, and this is the prototype for what we're going to do more. We're doing long-term holds. So the investors are coming in. So we've got a long-term hold. So there's a less variability. We're not trying to build for that the resale market immediately. So that's a leverage on we can see for cost savings. We've got private financing. So we're a little bit more nimble in the public funding markets. And so, but then lastly, voluntarily limited profit or return to the equity investors. So the equity investors are saying, okay, we're going to come in, we're going to put our money on the barrelhead, and we're going to get a return. It's for profit, but it's roughly going to be in alignment with the bank funding. So yes, you could put your money into a retirement account and send it off to Wall Street or something like that, and maybe they'll make money on it, maybe they won't. But we're also building in a market that has very, very stable and dramatically increasing property values. So we're anchored in a place where it's a tremendous amount of migration, tremendous amount of people moving here. So it's a fairly significantly lower risk if you can maintain a property value. And so the equity investors will get a return, but it's more limited than the standard for-profit housing developers want. So those 3 elements are going to feed forward, and then we're going to invest in our community. So instead of investing in Wall Street, we're investing in our community. And with that, we're going to be able to provide a stable housing for our residents. And we're calling this the little a affordable, because it's not using public funding. It is affordable, but we're using the private market to deliver it. So the top priorities for this team are, we want to make sure it's a dense building. So we're looking for these low-rise zones for apartment buildings. Family housing. One of the problems with a lot of the housing that's being built in my market is it's studios and single and one bedrooms. Well, a lot of the people who need this housing have families, and what do you do with a family of four in a one bedroom apartment? That's not a stable, healthy environment as it could be if we were to build 2 and 3 bedrooms. So with that, we can minimize the displacement, because there's commonly a lot of displacement. The site we're looking at, for future, is only 6 miles from downtown. It's 4 stops on the train station from downtown. So it's a high risk of gentrification and displacement. So we're going to work to minimize that. We're going to make sure it's healthy using the passive health methodologies, and then also stable. So we're going to stabilize our rents, stabilize the residents. So because it's a long-term hold. And then lastly, a top priority is low maintenance, because we want to make sure this thing works long-term. Secondary priorities: cost of construction, huge. You can only deliver affordable housing if you're in there and you're managing that upfront budget. Want to make sure it's passive house, also endeavoring to make sure it's low embodied energy, low embodied carbon. And did I mention low maintenance? Because the maintenance crew, well, you're looking at half of it. So I do not want to be out there on my evenings and weekends. I've got a day job. I want to make, so we're emphasizing low maintenance components in our buildings. So the Red Willow program, this one specific, it's a 7,600 square foot lot, had a single family house. It was well worn out. It would need a full gut retrofit, and it actually would be needed to be lifted out of the mud. So it was a worn out house. So we're replacing it. It also significantly upzoned. It went from what they used to call single family zoning to a low rise. So we're able to put significantly more units on the spot. So now we've got, instead of 1 3-bedroom apartment, we've got 12 apartments. We're able to do 4 per floor, 5 1-bedrooms, 5 2-bedrooms, and 2 3-bedrooms. So it's a significant increase in the density on this piece of property. It is maximizing it on almost every regard. Introduce Scott Weibar, the architect on the project. He was able to really shoehorn in under the zoning and land use codes, maximizing the density, maximizing the occupancy. So in the end, we've got 9,700 ice interior conditioned floor area. So it's 10,000 square feet. It's a good round number for this building. So here we are under construction. Here's the layout, the first floor. So there's 3 1-bedrooms and 1 2-bedroom. We're kind of Scott did a great job of minimizing the common spaces and circulation spaces, yet still providing some nice elbow room. So it's a welcoming place. But one thing you'll notice, there's a single stair here. Seattle has a unique code consideration that if you only have 4 units per floor, you only need 1 emergency egress location. You don't need a dual staircase. So many of you don't have that opportunity. Seattle has that in its code. So, because we're delivering family size units, 4 units per floor is kind of sweet. We hit a sweet spot within our code. So here's floors 2 and 3, where this is the 3-bedroom, and it's really roomy. People walk into that front room and go, wow, it's over 1,000 square feet for a 3-bedroom in an apartment building, a not publicly financed apartment building. And then there's 2 2-bedrooms and another single bedroom. So this is the floor layout for the floors 2 and 3. All right, challenge number 2. So that's the challenge of housing, meaning densifying, delivering good housing, endeavoring to meet the economic needs of a lot of our community. And then challenge number 2 is, in order to also meet those economic needs, is cost of construction. And we all know that construction has just plowed higher and higher and higher. So how do we deliver affordable housing within that? And also, when we have got to think about this, what's the premium for passive? So that's been one of my, thank you, Bev, for the introduction. It's one of my focuses has been to be able to deliver these great buildings using standard techniques, standard methodologies, and standard components in our buildings. But also standard trade experience, not needing to retrain our trades for every new project. So Scott did a great job. You'll see here the envelope area for ICFA 1.5, really great form on this building. It is a very, very nice looking building. We got a lot of great compliments. It's behind me here. When you go down the street, it has a different pop than a lot of the other cookie cutter stuff that's going up in Seattle. but it still has a really terrific form, really good window to wall ratio. And add it all up, we don't have to work that hard to hit the numbers on the right, the performance numbers. And so, um, I'm just going to just quickly show this. You've got the recording if you want to go through the assembly components. But what I want to call out is really when you're looking at the effective R value and U value, the only real difference to meet this goal was primarily met by the design. Scott designed a really efficient building, really efficient from an enclosure standpoint, efficient from a glazing punched opening standpoint. And with that, we didn't have to work much beyond code to meet our energy goals. So a 2x8 wall, pretty simple, right? A insulated truss roof. Okay, one difference is we do have an R20 insulated slab. Well, we needed R10 anyway per code. So we're just adding a couple more inches down below. And the windows, that was one of the premiums we paid for was a good window. That said, we are off of a state highway, a 4 to 6 lane highway. There's a lot of ambient noise from the environment. So the triple glazed window, it's nice and quiet inside this building. So I'll just go through a few details because we're all geeks on that level. One of my emphases in my buildings is if we can build our foundations as simply as possible, then wow. I mean, if we can get out of the dirt with a simple, straightforward system, then a lot of our economics have been met. So I prefer, if we can, just using a very traditional foundation system, call in the concrete team, build me a foundation. Okay, we'll have a few specific spots where we want to insulate. So these are interior bearing planes where we are separating them from the perimeter wall. We are insulating below them and around them. So this is that bearing line that we're then going to tie in with our slab. So, okay, but we can do this foundation condition. One of the most expensive problems with all of our heavy equipment, we're off to the races nicely. And then infill with our insulation and our air and vapor barrier. Okay, so with that, pretty straightforward. Some of you, we can talk about in the question and answer why the heck that we're doing our slab while we've got a building above us. That was one of the challenges we had on our planning with our planning our city. It's a little bit out of sequence. Yes, it cost me more, but we didn't want to stall our construction out for permitting issues. So then once we get from our slab there, we're going through, we're getting to our foundation to wall. One of the beauties of needing that little bit more insulation in our walls is that, oh, we need a 2x8 wall. Well, most of our structural engineers, including Scott's partner, Jeremy, are accepting the idea that a 6-inch stem wall is enough, especially when it's just a vertical load and not a horizontal load. And with that, our 2x8 wall structure projects out over the interior. We can get a nice thermal break from our foundation wall to the interior. You'll see our soils level is essentially at our grade level is essentially at our floor level. So our foundation projects above our floor line, but we were able to get a nice thermal break at the perimeter of the slab and at the bottom of the wall as well. Really simple detailing that my framer has never done a passive building before. My foundation team had never done a passive building before. We're just moving on with traditional materials and traditional trades. What we were bringing in was a specialty crew to do our air barrier, where we're using our vapor barrier at the slab and we're bonding it to our footing. And then we're using our stem wall. Then we're using the stem wall to make the transition to the outside, right? So, but still strategic location for passive focused trade team. Then when we're going vertical, we're just using a standard fully adhered membrane on our sheathing. And this was a up in the air decision about what we're going to do. It was going to be weather dependent, but we chose a fully adhered membrane WRB that is taped at the base of the wall right there to the foundation. So we're using the foundation itself as a transition component from interior floor to exterior sheathing. And then we're just going vertical. And the siders had never done a passive building before, but they were like, oh, this is easy. All we got to do is stick them on the wall, and it actually bothers to stick. So they did a great job for me as well. So I'm using traditional trades, giving them some spot training and moving on. Then we get to the top of the wall. Okay, we're coming up the outside of the wall. How do we get to the interior? Well, that was, again, a specialty component coming out there with a transition strip. But what was created on this one, Scott and I worked on this one, basically instead of using a specialty component, why not just use what we needed was a double layer drywall for our fire rating to our ceilings, so a double layer gyp. And what was unique and different about it was what do we do with all the mechanicals, all the lighting, everything that goes up there? So
Proceeding.
with oh, we were basically we created a very shallow attic for our equipment. Right, we have the transition. Our top of wall, we have a height limit. Ideally, we would have just been able to put an attic truss up there with a higher heel, but we were literally at the height limit of our building. So we actually had to create this little tiny shallow attic. So it's only 6 inches tall, but the drywall that we needed for our fire rating is above it, and that's our air barrier. Yes, we did need a second layer of drywall below. So we actually have 3 layers of gyp at our ceiling at this to cover this service cavity, 2 above, 1 below. So that's a little bit extra, but not too bad. All right, so that's our enclosure, fairly, some unique details, but targeted. The other challenge we've got in our passive buildings is how do we deal with our HVAC? Well, I like to think it as Chris Benedict said, it's heating. It's not HVAC, it's heating, it's ventilation, and it's air conditioning. 3 separate components. Well, we can commonly combine H and the AC, but we need to keep, in my mind, the ventilation separate from that. So the challenges of HVAC and how do we deliver these in our buildings? The priorities from the team. All right, we want to make sure we need cooling in our buildings. Historically, our neck of the woods would not, until 3 years ago, we would not be thinking about putting cooling in these buildings. We're just in an area where we generally have had decent enough summers that we haven't needed cooling. We could night flush our buildings. That said, we had more people die literally from heat exposure during a heat dome a couple of years ago than have died that have passed from hypothermia, cold weather exposure for decades prior. So we now need cooling. The changes in our weather climates have mandated it. Well, we're also going to all electric anyway, so heat pumps to the rescue, right? But how do you get a heat pump for a 1-bedroom apartment that only needs a trickle? So less than 1 ton, and not having a farm on the outside. So what we do out here though is we put in heating in the bedrooms, separate standalone heating in the bedrooms. Because if you don't, people plug in a space heater anyway. So we wanted to include that heating there. But we also want to make sure we're minimizing the impact from our heat pumps. We want to manage our refrigerant quality. Ideally, we're not putting in split systems, so we're getting the potential for leakage as well. So with that, why not get the holy grail and get low GHG refrigerants in as well? And did I mention maintenance? Okay, we don't want to be maintaining these pumps. I don't want to be calling out my HVAC maintenance teams to do them also. So those are our priorities that went in, the challenges that we were trying to solve. The solutions we came up with were, well, let's use the Epica one. It's a package unit that goes on the wall. Pretty efficient, right? It's new out there. It's a lot of good promise for us, right? Looks pretty good. Everybody kind of, and it's the right size for our units as well. And they're packaged and they've got R32. How fantastic. The silver bullet we've been looking for, right? And then just putting a small electric heater on the wall in the bedrooms. So, and then talk about a low maintenance system, right? Everything's glorious, right? At least on paper. Well, crashing down on the rocks of reality. Electric resistance, well, that's simple. We all know how to do that, left, right, and center. Very affordable. The wall mount unit, what? You want to put what in? What's it called? What's it look like? Where's it go? Where do you get it from? Like, how do you install it? Who's going to install it? My HVAC installers justifiably were slightly terrified of it because they'd never done it and they didn't want that callback. So we ended up self-performing that one. We ended up ordering 6 months early and got them five months, 3 weeks after we ordered them. So it was really good. We ordered 6 months early. And yes, they were coming directly from Italy. Well, Epica has, from what I hear, solved that. They now have distribution out of Ohio. So they're solving the problems as well. But when we started, it was really rough. But also, how do you do the layout on the wall? How do we attach them to the wall? How do we have a continuous air barrier? Because this thing is going on the inside of the wall and it's got 2 8-inch holes to the outside. Oh, and even though we paid for R32, they came with R410A. So, because they've got some production and UL considerations for getting in the States with it. So massive learning curve. And from an air tightness standpoint, ouch, I'll just say that. Okay, it worked. We got it to work, but the learning curve was brutal on it. So all in from a cost perspective, it's about $7,500 for the heating and cooling per unit. This infrared image on the left, it's 15 degrees Fahrenheit outside when we're taking this picture, and you're seeing the air leakage from the unit to the wall. So we had our air barrier transition from that membrane through a custom made sleeve that came and then transitioned to the drywall. And that's the air leakage between the unit and the drywall itself. And yes, we solved it, but we couldn't solve all the problems. Here we're seeing a smoke test of the unit itself with the cover off. So they're going to leak. They've got 8-inch holes in our building, and there's definitely a risk of water intrusion. And something that was just brought up to me the other day, I got to get somehow through that hole and clean the fan coil or the coils on the condenser inside that unit. Well, so there's going to be a maintenance cycle, and I'm likely going to be pulling it off the wall and putting it on a bench to clean it up every 5 years. So not a silver bullet, but a bullet that we can use to get to the end. Now I want to talk about the V problem, the ventilation problem. Hugely important in our buildings. We all know that. We hang our hat on the fact that we've got really good interior air quality in these buildings, and that's provided by limiting contaminants and also providing ventilation. So range hoods, well, get ready, everybody, because exhaust range hood ventilation is generally going to be required. Okay, some of you are already doing it. Some of you have solved this puzzle. I historically, in the building like this, would have been putting in recirculating range hoods. Well, I'm no longer allowed to, and many jurisdictions are not going to allow it as well. So exhaust range hoods, but what about the makeup air for these things? What if all 12 units turn it on simultaneously? Well, there's a very rare, that's going to be extremely rare event. What we're providing ventilation, we're providing fans, and our fans are actually fairly programmable. So we're providing semi-centralized ventilation. That's meaning per floor, and what maybe they can provide the makeup air. So that's the priorities we put through. That's and Galen, I see you're here. Thank you so much for the work you did on this. Where we're providing makeup air for the range hoods in for the times for this building. And but we also want to make sure it's an affordable ventilation system. So then the last priority is going to be getting that auto bypass. Why? Because we have these beautiful summer evenings where we have very low humidity and it's in the 60s and 70s, and how brilliant it is to have your ventilation just turn on and night flush the building. So those are our priorities, the solutions we came up with. Drone exhaust Energy Star range hoods, 300 CFM rated. Remember that number for a moment. We're doing makeup air through the HRVs. Basically, we're slightly pressurizing the building for the times when the range hoods are going to slightly depressurize the building. So ideally, a balanced ventilation, we're providing the same amount of supply and exhaust. Well, we're providing a little bit more supply for those moments when the exhaust range hoods kick on and we would otherwise be depressurizing the building. And I'm going into FIAS to negotiate, hey, maybe I can do it just part of the day and not through the night as well. So that not take that energy through the night. So we've got one Zender Q600 for each floor. So there's 3 total. And then I've also got a small Panasonic ERV for the egress locations. So in order to not need smoke and fire dampers, we're providing the necessary ventilation for the egress corridors with its own standalone ventilation component. And all this in about $6,300 for the hard costs for installing this ventilation system. It's all hard piped. We didn't use any custom soft ducting, and the reality of it is from the exhaust. The reality of the exhaust range hoods is those things, they don't move much air unless you really design it appropriately. So we have a 300 CFM range hood, and we're getting 120 to 160 CFM actually once it's installed. So it actually wouldn't comply with the new Washington State Code. I'm under the slightly older one, so they're not going to look over my shoulder on it. But the new ones, I'm going to have to provide even larger ducting for lower static pressure on the range hoods. Okay. So we're not getting the flows that 300 CFM stamp, not getting it. We do have a damper at the exterior wall, a custom damper at the exterior wall. We've got some longer runs, but honestly, the length of the runs is not the constraint on why we're not getting that 300 CFM flow. So oversight is absolutely essential. airtight metal ducts are really tough. My team, Ricardo and his team did a great job. We made sure we checked it and tested it. But one thing I highly recommend, and I'm going to do on all my projects now moving forward, is to pre-commission the ventilation flows before I cover. So there's interior dampers located in the ceilings and the walls. Where are we at? No, it's a later picture. Sorry about that. So we've got dampers within the ducting distribution, and so we pre-commissioned our ventilation flows prior to cover, and it made it almost a breeze when it came time for final building commissioning. Now, sound though is pretty rough to tackle when we got rigid ducting. So still, that's one of the complaints we're getting from the occupancy of the building. So yeah, so here's our ventilation lines. We've got dampers built in there that I don't want to have a access panel to. Here's the one HRV for the third floor, and here's the the Panasonic ERV for the corridor spaces. And you get to see a cute picture of our battery storage as well. Rinse and repeat, as Bev said, rinse and repeat. All right, the goal here is I'm one of many. I want a lot of people to build these things because we've got a massive housing crisis, and especially affordable housing crisis. And that missing middle, who's going to meet that? So rinse and repeat. We've got good results to date. The occupancy started just a few months ago. We've got 10 of 12 units rented out. 9 of them are occupied. We've got 2 remaining 2 bedrooms. What's interesting is we thought the 2 and 3s would go right away, but one of the most popular ones actually was the 1 bedrooms. So interesting consideration. Here's the one of the PV inverters. And we're producing a ton of energy, and it's even for Seattle, that element is doing great. So Bev wanted me to put in some financial statistics, and thanks, Bev, for making me do this. So total development cost, the whole project, 4.7 million. Okay. Well, a lot of that is land cost. A lot of that are other considerations. So, but if you look at TDC per unit, average, all of them, just under $400,000. If we just look at construction costs, 3.5 million. Okay. But Seattle has a 10% sales tax. We also, the solar and storage was paid by a state grant. That's the one piece of public funding we got. We won an award to put in a distributed energy resource, 50 kW on the roof, 20 kilowatt hour battery storage. So that is, I like to put that in a separate bucket. When we designed the project originally, that wasn't included. So that was an added thing that we won a grant to provide. We're working to provide that. So if we pull those 2 out, construction costs are just below 3 million. It's as you saw earlier, it's 10,000 square foot building. So just under $300 a square foot, not including sales tax. So cost per unit, and if you pull out the sales tax and storage, 250,000 per unit. So if we look at cost per bedroom, which is another metric to look at when you're doing multi-bedroom rather than just studios and ones, we're actually getting pretty low, less than 170,000 per bedroom, and less than 143,000 if you take out the sales tax. So the premium, I'm estimating it. I'm still doing the final math. What's the passive premium on this? I think it's more in the 3%, but I want to be conservative and say it's 4% right now. We paid for better air tightness. One of the caveats that I have for my district, my region is our baseline is high. We already needed balanced ventilation in a building typology like this. So I'm only providing better balanced ventilation. We already needed more than R21 in our walls. I'm only doing a little bit better than those components. We already needed R10 below our slab, so I'm only doing a little bit better. So my baseline was a little higher. Common triple pane windows is actually not uncommon here because of the sound mitigation concerns. So add it all up, I'm personally thinking it's more in the 3% range, but I still got to do that with me. Big thank you to the team, VY Architecture, Scott's here. General contractor at Cascade Built. I hired Cascade Built, and then they hired me to run the job. That's why I'm way too immersed in it. But good friends over there. Stengel Engineering, thanks for being here, Galen. Artisan Electric was the solar contractor, and then we were the developer. So Scott's here. He's going to join us in a moment for question and answers. And Galen's here too. Galen can join you for question and answers. Scott with Hannah and Thomas, a great architecture firm based in Boise and Salt Lake City. And many of you might be familiar with this beautiful project that Scott presented not too long ago. So, and here's our project during construction, pretty fun. Just a big thank you to Skylar for the drone pilot on this one. Thank you all for listening to my ramble here. And if you want to contact me, that's my email address. I had a good conversation with Christoph Irwin from Positive Energy. It's on the Building Science podcast. Zach's going to put that in the chat if you want to hear more about it. All right, so that's that.
Amazing stuff, Dan. Bravo. So we'll let you have a sip of water and refresh, and we're going to head over to a sponsor break. So sponsors.
Yeah, thanks, Sean and Dan. That was fantastic. Thank you. So cool. So I want to take a moment to thank the fine organizations that make our work possible here at Passive House Accelerator. So a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Ingwe Architecture, Glavel, Minutair, Partel, Rockwool North America, Stocorp, and Zola Windows. Thanks to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050. And thanks to our patron sponsors, Brennan, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Absolutely. Thank you, sponsors. Thanks, Zach. All right, we've got the question queue lined up. Dan, hopefully you're ready. I start off with Justin. You know what, Justin, I know you had two questions. Why don't we just start with one, and we'll see where the time goes. So, Justin, you can pick one of your two questions to kick things off.
Okay, so I'll go with the non-pH question, actually. So I noticed that you didn't have elevator, just questioning mainly from ADA point of view. You know, how does that work for, you know, 3-story building?
Right. So
Mhm.
Scott, maybe you can talk to that one. So I'll call out Scott here, but in generally the level one that has, so we needed to provide, my understanding, 1 type 1 and 3 type 2. With those 4 units on the first floor, we're able to meet that requirement. One is a fully ADA accessible. The other 3 are type A, type B. So we've got 1 type A and 3 type Bs, and that is met with just by units on the first floor. And personally, you know, that walk up 3 flights, nobody's complained. We've got families, 3 families on the top floor and one single person, and so everybody's like, oh, it's not that far, and it's 3-story walk up. Scott, any comments on that?
Yeah, I guess just to say that we were just required to have 1 type A unit for the total of 12 units, and we could provide that on the ground floor, which is accessible. So the ground floor is completely accessible, but not required to have an elevator in this low rise situation.
Yeah, I imagine that's a great cost savings. So that's great.
Cost savings
Absolutely.
and floor area savings. I mean, every stair you can pull out, every elevator you can pull out, instead every floor you can now provide it for living space.
Like every time, Justin, on the move-in days and move-out days, those are the tough of, you know, those king-size beds that have to figure out, you know, getting around the corners and stuff. But otherwise, just hire good movers, and everyone enjoys their step counters and getting those extra steps that we all need nowadays. So great concept, and glad that the code allowed it. So yeah, I had a question, and again, I think I know the answer already just because of the cost, but you know, would you have considered prefab, and did you, or did you just stick to your framing crew that you kind of knew was able to do a 2x8 wall?
People accuse me of being romantic about the carpentry trade, which I am. But I was a framer, and I know that we can build these buildings really expediently and quickly and carefully on site. If we didn't have, I mean, if I didn't have a Rolodex full of framers, if I didn't have a Rolodex full of competent siders, my baselines here is that my trade group knows how to install an airtight building. We've been all in the Seattle market, been doing our air tightness testing for a decade on all of our buildings. So our baseline is a lot higher. So, and I've basically, I like to work with trade professionals who are curious and want to know what's next. And I find no lack of them. I've been on, I don't want to denigrate the offsite construction industry, but I think the opportunities we have to deliver these buildings, I mean, that building, like we can build these in so quickly on site without needing the infrastructure, without needing the transportation costs, without needing the constraints of delivering a large box on a crane. We can just deliver the raw materials to site. So I'm a proponent of that. I'm not denigrating the offsite construction, but I don't need it.
Yeah,
Awesome.
I would add maybe too on the just this building was it was very much shoehorned into that site, and we were messing with the grid line spacing. Each unit was slightly different, and I think that it would have been difficult to have sort of a standard module that would have worked well in this particular site. So I think this building was almost just too specific for prefab, but if we had more room and you could repeat a module, then it might look more interesting to do that.
Interesting, gentlemen. So just a quick little segue. On Friday, Reimagine Buildings does have a prefab summit, and both Dan and Scott are not invited. So appreciate your comments, and we'll continue on. Bev, you had a couple of questions.
Yeah, well,
Just pick one, just because we got a lineup here.
Ginger just asked a more detailed version of my first question, so I'm going to read her question if that's okay. Which is, the investors, were they like certified investors? Who were they? What kind of, and how would someone set this up elsewhere on the money side?
So I know just enough about this piece to be really dangerous. So I want to be very, very, one of the beautiful things about the team that we have is Ginger Siegel, who's on this team, knows that game. And that said, we are still learning it. Washington State has one of the most constrictive investor regulatory bodies that in the country. So like I can't ask you, hey, invest in my project unless I'm unless I'm a certified investor or organization. So we I mean, like many prototypes, you've got to create it yourself. So through personal contacts, we were able to aggregate that initial funding. And then now that we're trying to hit that rinse and repeat, now we're creating the structure that would move forward. But that said, so that's the extent of my knowledge from an investor side. There's going to be local folks who can help navigate that very, very complicated field.
Yeah, lots of insight there, Dan. Thank you very much. Because I think a lot of us in the community, again, want to become developers as you've been a builder, because it's kind of the path of your kind of career, and you kind of know where the money gets to. But also too is, for the individuals here that get to enjoy a passive house and get to share those stories is great. And the fact that, again, you looked at those costs, and I actually can't wait to send this video to my current clients, just to give them some of the insights and some of the struggles that we're having. And again, that you're looking at a lot of the same questions and concerns that we're managing. And again, you've got those lessons. So again, lots of respect for you and this project team, and thanks for the investors to pull this through.
Can I add one comment on this? And again, this is coming from my colleagues' knowledge. When you're endeavoring to hold this long term and you want to reduce the impact on the project from the investor's standpoint, okay, we are getting approximately equal profits, but our equity, we don't need to pay back the principal. So when you're thinking about a mortgage on a piece of property, you're paying the interest and you're paying the principal back on a certain standpoint. The long-term hold of the investment group, in this case, is, well, 10 years. So the equity is maintained from the investors in the project. So we're not having to pay down the principal for that first 10 years. And then property values will have significantly increased, and we can refinance in those investors who want to get out. But So it's very much behooves on this project having more that building up the equity investors rather than just having to go to the bank, because that was allowing us to provide those lower bids.
Excellent, thanks. So moving along, I know there's a couple ones about the wall that we will dive into. So Paul, sorry, Reed's first. Reed.
Yeah, my friend, always good to see you. And my compliments on that project. It's beautifully clean and anyway, it looks really nice. So I'm questioning, was there a design process or decision on your WRB that you, I think, used sheet good versus liquid?
The original design was to use a fluid applied, and on a project of this scale, I literally couldn't find a sub who would do it. So it's just too small. So the big siding subs, it was just too small for them. And this is the trade group I was looking for on this project, is essentially those who are working on townhomes or like, small market rate, small multifamily projects. And those folks were just kind of looking at me sideways.
Right.
There are some products that are out there that it could have utilized, but in this case, and we were we to be building in the wet season, putting that WRB up in the depths of the wet season, we might have gone without root anyway, but it was already pushed into the spring shoulder season. So it went up quite well because our sheeting wasn't wet.
Cool.
So that's one of the fleet of foot decisions we made during the course of construction.
Yeah, I think we're going to dive into this wall assembly. There's some great questions about it. So Dan, describe your wall assembly a little bit more detail. If you want to pull up the one slide that talked about it, there was questions. I mean, Reed's point too about, the WRB and air barrier is interesting. I know I'm seeing a lot of people jumping from a membrane to a self-adhered, because again, if you're fastening through things, you're worried about maybe trades managing your air barriers, so you're spending. Sometimes, like membrane is a cost, and so that self-adhere is like 3 times the cost. And then there's of course the concerns about 2x8 wall and and needing a Wolfe analysis to see about the durability and the dryability of the wall assembly. So, and then of course, just kind of reiterate again is, just how come you didn't do prefab and looking about those things. So you got about 5 points this wall assembly. I was kind of waiting until you're going to bring up the slide to show it, and I don't see it. So I'm just going to turn the floor over to you in the final 15 to talk about your wall assembly. Oh, you're muted.
I'm endeavoring to actually bring up the wall detail.
Sorry.
Scott, hope you don't mind me sharing your details.
But while you're doing that, there's a couple of comments that again, bravo for the slide deck of showing the detail with a photo. Again, great slide deck for showing the example, and I know I took snippets to add to future presentations potentially from Mr. Dan Whitmore's slide deck of excellence.
Thank you, Sean. So here's our. So if we're going the total wall, all right. I understand our walls control moisture in bulk form. Our walls control moisture in vapor form. Our walls control transfer of heat through them as well. They also need to shed the water on the outside. So we've got all the 4 control layers plus the water shedding surface. They need to do a lot of work. One of the challenges as our walls get thicker and thicker and thicker is that exterior sheathing gets colder and colder and colder and more likely to see condensation. So there's a lot of communication in this particular community about making sure our walls don't rot out. Well, what's the risk of there? Okay, we're controlling risk vectors. So I'm controlling risk on this wall so I've got my cladding, and we're using party a fiber cement in all cases. That we're then providing a 1/2-inch rain screen cavity behind it that is continuous from top to bottom. So even at this location here where we've got transitions, we're providing the ingress of air at the bottom. We're then letting the air travel vertically through that rain screen cavity and exit at the top of wall. We're going all the way up. we're allowing the air to leave. The soffits are not communicating airflow with the walls themselves. So we're not dumping our wall moisture into our roof. So that, with that said, so we're drying the wall out quite well. We are in a wet environment. So one thing we need to be worried about is initial wetting during construction. Well, then we also, so we regularly test the moisture content of our walls before we start putting things in the way from the inside. And so my moisture content in my wall sheathing was quite low when we went to insulate it. So we're not doing the built-in moisture. We've got good at continuous cladding for our water controls, our bulk water control. Then we've got that continuous self-adhered membrane in the inside. So I'm confident that we're not getting bulk water either in the sheathing to start with, or hitting it from the exterior, and we're allowing it to dry to the exterior. We don't have exterior insulation on this building, one, because we don't need the R value, and two, because as long as we're mitigating against the risk factor of that sheathing, we're not going to see the damage to it. I choose plywood. So I'm minimizing my risk by choosing a sheathing product that is a higher, what we call safe storage capacity. And so OSB I've had problems with. It takes on the moisture and it starts to degrade, whereas the plywood doesn't. So add it all up, I feel like I have a very robust sheathing component that, yeah, it's going to see some minor water buildup in some locations, probably on the north side, but I'm confident that it's going to dry out seasonally. And then how are we minimizing the moisture from the inside? Okay, a lot of project of this scale, they would, the building enclosure professionals would strongly recommend putting a smart membrane right behind the drywall. Okay, that is a risk I accepted by not including a smart membrane right behind the drywall. It is actually a very common detail to do in multifamily buildings in my region, using plywood and then a smart membrane right behind the drywall. We chose to rely on the PVA primer to control the vapor coming out these units from the interior. But thirdly, we've also got a really good ventilation system. So we're not going to see the buildup of interior moisture generated by the occupants because we are pulling the moisture out. It's one of the reasons I chose an HRV to provide the balanced ventilation in this building, because even on a cold, wet day here, where the air outside is drier than the air inside from an absolute humidity standpoint. So add it all up, I'm managing my interior vapor drive with my ventilation system. I'm managing the vapor drive through the interior wall finish with my PVA primer. I'm managing the risk to the exterior sheathing by making sure it's a higher safe storage capacity. But lastly, I guess the other thing is that wall sheathing is going to be warmed up because it's only 7¼ inches of insulation. Were we to move to 10, 12, 14 inches of insulation, that sheathing would be colder for longer. But we actually are moving some energy through that exterior insulation by optimizing it down to just a 2x8 wall. All right, that was my deep dive, Sean. Any more on that?
There are a couple minor questions for it, but I just want to make sure that if we didn't have a construction tech already lined up for next week, we would have just clipped this section, planned it on next week, and just call it another show and continue things on. For those that miss it, because it's so detailed. There's a couple questions. So I apologize for bringing the people on. I just want to speed this up because we do have a bit of a question or a queue. Did your wall assembly require a code review, an exception, or a building envelope consultant?
Not at all. It's fairly common practice in my region, and FIAS accepted it as well.
Awesome there. And then just another detail for the seal sealer on top of the foundation. Did you not have something in there?
So at the top of foundation, so foundation to wall plate, we absolutely have a sill sealer there, but that's only to stop the capillary effect of the wet footing and the wet stem wall. We don't want the water that's in that stem wall to get up into our plate. But a sill seal, the top of foundations, especially when you're using, economically driven foundation crews, it's not going to be flat. It's not going to be perfect. There's no really good way to make an air barrier transition from top of foundation wall to wall plate. Oh, and besides that wall plate, is a, you know, it's a piece of pressure treated ham fur that's full of checks, cracks, knots, and who knows what. So I like to make a transition from my sub-slab air barrier directly to my stem wall. My 6 inches of concrete is a bomber air barrier. Good luck getting any air intrusion through that, as long as there's no voids or cracks. And then making that transition from that stem wall directly to the sheathing. So using that chunk of concrete as a component, I find much less costly, much less intrusive than trying to make a top of foundation transition.
Yeah, I mean, I also love too is by understanding how the wall works from a building science standpoint, then you can look at cost-effective methods. Because, you know, I would agree with you. I would want to put in another smart vapor control layer as an air barrier, but you said, okay, well, by going with, you know, the wall assembly we've chosen, and the you know, the paint on vapor control layer, then you kind of put more money into that self-adhering membrane and, you know, really work on it. And so that kind of leads to the next question is, you know, maybe I missed it, but just your blower door score.
Oh, so we actually did really great in our preliminary blower door. So do I have it? I don't have it up. So our final one was 0.036 CFM per square foot at 50 pascals. So the FIAS limit is 0.06, and that was even with the range hoods, even with those exhaust range hoods. So on the depressurization side, we were at about 0.02. On the pressurization side, when those baffles were being blown open, we were about 0.07. So, but the average, actually 0.06. So the average came out at 0.036. And from a ACH standpoint, I think we're at 0.31 ACH 50.
Yeah.
So even
Awesome.
with those methods, and you know, it was kind of fun when we did our preliminary blower door tests. We were all there, we're ready, the crew's ready to run around and fill holes and all that sort of thing. We fired up the blower door, and we were like, is that thing working? It literally was like, that was the comment. Is that thing working? We had a duct blaster pressurizing a 10,000 square foot building. It was able to get it up to 150 pascals of pressure with a 1500 CFM fan. And it actually would go farther. I just didn't want to burn up the duct blaster.
Yeah,
So, so it's totally achievable. One of the beautiful things now with accomplished practitioners out there is the air tightness is not something to be afraid of. It's just something to achieve. So,
yeah, I think that's exciting when you have two tables. You've got the table full of your tapes and your you know, caulking guns ready to go run around, and then your table of donuts and coffee, and everyone says, "Oh, and we're going to table 2, and we can celebrate."
yep.
Yeah, lots of fun. Okay, so I'm dominating the conversation. Let's go back to people's questions. I believe Bev, you were no, sorry. Paul had a question, and Paul, hopefully I didn't already ask it. Paul, are you still with us?
It looks like Paul has no mic.
Okay. Let me just find the question. So actually, Paul, while I look for a question, I know Salvatore had a couple of questions. So Salvatore, you go next, and I will pull up Paul's.
Hey, Dan, thank you for your presentation. Can you hear me okay?
Yes, can.
Yeah, I just wondered, you know, that's the disbalancing question regarding the oven vent. I often wonder if the conversation with Zender may have been had, not even through you, maybe just, and if they're well aware of the conditions we're trying to meet. And I do believe that there's going to be a greater propensity to want to exhaust to the exterior. And I think it can be done if we have a really good, you know, damper that can do the air sealing when it's not operational. It would be kind of nice, and I'm not sure if you talked, and what do you think about this? Discussing with Zender, hey, look, we want you to get the feedback from our vent. So when the vent is on and we're trying to throw out 300 or 400 CFMs, can you intentionally disbalance the building so that we can accommodate for that condition just for that portion of time? It would be, I think it's very possible for them to do it. I think they just probably need to incorporate it within their kind of feedback and controls. What do you think about that?
I'm going to I see Skylar's here at this meeting. I think maybe Skylar's, you got capacity to activate your microphone. I know Zender's looking at it. I also know other ones are looking at it. We've got a project here in Seattle, colleagues are building where they're talking with Broan. Broan's come out with a brand new ventilator, which is high performance. And basically, you're absolutely right. The technology that's running the fans has the capacity to boost one side or the other. The project here, group O'Brien 360, is working with Broan to create a relay. So when a range hood is activated, there's a pressure component within the ducting, which historically we would use to activate a motorized makeup air damper. Well, it's actually going to boost the flow of the one side. One of the challenges for me is, I didn't go into my ventilation systems. You know, I've got 12 apartments here. I don't want to have to go into 12 apartments to change my filters. I don't want to have to go. I don't want my 12 tenants to have access to the ventilator, because the likelihood that they're going to adapt it or change it. So from a building owner standpoint, from an operator standpoint, I want semi-central or fully centralized ventilation. That's my preference. So that was a priority. But so to get the ventilators to boost for that range hood or that range hood or that range hood would be a fairly tricky component. It sounds like you might be doing single family or multifamily where it has unit by unit ventilators. Definitely great opportunity there. The technology is there. It's the electronic components. And I see Skylar's microphone is on.
Yeah, hey, Dan. Yeah, I mean, this is something that's been requested from Zender for years, and they're aware of the issue. I think that the reluctance is there are some issues if you have too much, if the supply air is not balanced with the return air, you're going to get really cold duct temperatures during winter. And so you'll need to have a pretty beefy preheater. So that way, like if you're bringing in an extra unbalanced 200 CFM of air through your supply side, and that air is comes in at below the dew point temperature of the space, then you could potentially get condensation issues on your supply ducts from the Zender. And so I think there's some limitations to that, which they without a doubt would have the ability to like sell a earlier pre or post heater to accommodate that. But they're aware of it, but they don't seem to have a lot of interest right now. Like the main European Zender doesn't seem to have an interest in adding the function, but the local Zender reps all want that feature and would love to have it. And it's just Zender is not, doesn't seem to want to implement it.
So one of our winter design temperatures aren't that low here. I think it's 23 degrees Fahrenheit. So I'm not gonna see that risk. Also, because it's a big volume building, the calculations, FIAS has a intermittent range hood calculator. We only need to provide, the whole building needs to provide about 200 CFM across the 3 ventilators, additional airflow to make up for the intermittent use of range hoods throughout the building. So this is probably a special case here.
In the interim, Dan, do you think that it's pretty agreeable in your mind that at this point we just deal with an inflow open vent that conceivably, to bring in that makeup air and then preheat that air through a coil that kicks on to deal with the tempering, or maybe the tempered air is introduced in an unintrusive area, like a basement, unfinished basement or something. And has anybody been able to find a really good damper that can get a nice air seal? I think that's my biggest challenge.
Actually, have one right here.
That's insulated too, by the way.
Well, you can provide supplemental. I happen to have one sitting on my desk. Mm-hmm. We put one of these in a 65 unit apartment building. It's still not airtight, but it's they are out there.
Who's the manufacturer? It's hard to see because of the backdrop.
Sorry. Yeah, there we go. Can I put a hole in front of me? Nope, that doesn't even work. All right. This one is by Ultrazone. I know there are other manufacturers out there, but this one is by Ultrazone. But it's got a really good consideration actually inside there.
Thank you for that.
Yeah, they absolutely, I don't know, Salvatore, where are you building? where you're designing cold environments. You're on mute. Well, regardless, to
Sorry about
Skylar's,
that. 5A.
yeah, you're cold. You're gonna need to reheat that.
Yeah.
And you don't want to put it in that unconditioned basement, because that unconditioned basement sure shouldn't be connected to your passive house enclosure area. We don't want the air coming in there then going up above. So you're gonna need to condition that makeup air.
All right, everyone, great stuff. I apologize if I hogged the final 15, but I knew the wall assembly was an interesting topic and a couple of questions raised. But we've hit that time where we've got to get back to work or back to doing whatever we were doing, or continue on your own passive house research by again listening to the magazine or listening to the podcast, checking out a magazine, and getting ready. Because again, Wednesday night, Thursday night, boom, we're here Friday with Reimagine Buildings Prefab. And yes, Dan, you are invited. I again, I apologize for teasing you. I really love this project. There's so many great things about it, and there's a couple kind of takeaways. Again, is building buildings for the money, for the investment side, and then building buildings to manage humans is always so tricky, especially when they don't understand maybe the building science or how to change a filter on, the right cycle, and you having to manage their behavior. So lots of great insights and what you've done with this project, and again, beautiful presentation, beautiful delivery. And at that point, Dan and Scott and your team that came on, Skylar, great to have the support network show up. But it's time for Kim to hit the ejection button, and we can get back to what we're up to.